examples of graphing sine and cosine and kind of some moving around a little bit. Because here we're multiplying by 2/3, so there's my b, 2/3. And so that's just going to change my period. So normal cosine period length is 2 pi, and we're going to divide that by 2/3. Okay, so dividing by 2/3 is the same as multiplying by 3/2. So the 2's will cancel and I just get 3 pi. So my period length is actually going to go to 3 pi. And we can kind of see that here. I'll go ahead and try to move this b here to 2/3, which is 0.67. Okay, I'm probably not going to get there. 0.7, 0.4. Maybe I can just enter it in there. Probably not. Okay. Well, anyways. Somewhere in there. Okay, so here's the old one. So here's what it looks like. So it changes a little bit. And 3 pi, that's about like 3 times 3 is 9, so it's about 9 point something. So over here, we're probably about right in, well, we're probably maybe right in somewhere a little past here, maybe like right there. Okay, so that's what it kind of looks like. And so as we graph this, our y values are going to stay the same because we're not multiplying anything of this. So our y values are still going to go 1, 0, -1, 0, back to 1. So my graph is just going to look like this. Just my x values are going to change. So normally I start at 0, and then I need to find my interval length. So I know my period. I need to divide that by 4. So 3/4 pi. So I start at 0, I add 3/4 pi, I add this distance, my interval length, and I get 3/4 pi. And I just add another 3/4 pi. So that is 6/4 pi. And then I add another one, which is 9/4 pi. I don't even care if you reduce this. And I add another one, which is a 12/4 pi, which we can see is 3 pi. That equals 3 pi. 12 divided by 4 is 3. So there's the graph of that one. Okay, let's look at another one. Okay, so while this loads, let's go ahead and look at what our b is. Our b is 3. And then we have an a of -2. So that -2, that's going to affect our y value. So our normal y's of sine, normal y values of sine, I like to do this. I say y values of sine. They are 0, 1, 0, -1, back to 0. Okay? And then all I do is just multiply by my a. So multiply by my a, which is -2, so that's still 0, that's -2, that's 0, that's +2, and that's still at 0. And then I go ahead and graph those. So 0. So then you can just plug in your y value. So 0, now at -2, so that negative out front, remember, it flips over the x-axis, so it goes down to -2 at my first interval. And then second interval back up to 0, third interval up to +2, and then back down to -2. So you can see, other than the flipping around the x-axis, that this graph kind of really looks the same as our normal sine. But these x's are going to be different. So because we have a b as well, so that 3, I'm going to take my period, which is normally 2 pi for sine, divided by my b, which is 3. So 2 pi divided by 3 is 2 pi thirds. Now, so that's my period length. So that's normally starts at 0, and it's going to go to 2 pi thirds, because that's a whole distance of 2 pi thirds. And then I can find my interval length, and that is just taking my period, which is 2 pi thirds, and dividing that by 4, which is multiplying by 1/4. So those 2 and 4 will cancel. So I get pi sixth. So I'm counting by pi 6. So because sine and cosine are really great because they start at 0, so I'm just adding a distance of pi sixth, 2 pi sixth, 3 pi sixth, which I could reduce these if I wanted to, 4 pi sixth, which will reduce to 2 pi thirds. And so there you go. There, it's all graphed for you. Okay, so here's another one. Here's my a. Again, that negative's going to flip it. My b this time is actually pi itself, just pi the symbol. Okay, so I can do my period, which is just 2 pi divided by pi, because my b is pi. So my period is actually just 2, the distance of actual 2. Okay, so that means I'm going, cosine goes from 0 to your normal period length, which 2 pi, but our period is 2, so that's going to be 2 at 2. And then I have 4 intervals, 1, 2, 3, 4. Okay, and then normally starts at 0. Okay, and then my a is going to change. So normally my y values, let's do it over here, y values for cosine are 1, 0, back down to -1, back up to 0, and then back up to 1. Now I want to times them by my a. So that becomes -3, 0, +3, 0, and -3. So I'm just going to change this value to -3, 0, +3, 0, -3. So then you can see it kind of looks the same other than being flipped over the x-axis as original cosine. Now I just have to change my x value. So that's taking my period, finding my interval length. So that's my period divided by 4. So 2 divided by 4, which is just 1/2. So 0 plus 1/2 is just 1/2, plus another half is 2 halves, 3 halves. I could reduce this if I want to, 4 halves, which is 2. So there you go. My x-axis is labeled, my y-axis is labeled. I got my smooth curve. All done. All right, last part is determining an equation. So normally we want to take an equation and graph. Now we're going to look at a graph and write the equation. So normally we have y equals a sine of bx, or y equals, or f of x, doesn't matter, a cosine of bx. Okay, so first thing you want to do is maybe find out where it's starting to repeat at. Okay, so here when we look at this, we want to kind of figure out where it's repeating at. So we look at our original, which is, you can't probably tell, but here it is, right here. So that's normal cosine, is right there. And so what this looks like is it's normally starts at 1, but here we have our first value because normally we're at 0 for our x. Well, our first x is at -2. So that's going to tell me that my a is actually -2. And how I can kind of tell it's cosine as well is because that first value of x is starting at a number besides 0. So if I start at 0, that's going to tell you it's normally at sine. But really, you could write it in both of these. You could write this function in terms of sine or cosine because really they look the same. They're just kind of shifted over. Okay, and then normally, where does it start repeating itself? That's how we find our b. So this keeps on going. Maybe I should use a different color. Red, I guess. So I don't have another repeated answer until about maybe like right here. Okay, so my repeated answer is way out here at that's 18, probably like 21. So it finally repeats itself at 21. So there's my my period. So my period equals 21, but my period is 2 pi over b. So 2 pi over b equals 21. Now I have to solve for b. So 2 pi over 21 equals b. So there's my b. So now I can plug in my b and I can plug in my a, and this looks like cosine, so I'm going to do cosine. So y equals my a, which is -2 cosine of my b times x. And so that's what that one kind of looks like. You could write it in terms of sine. So if I'd write it in terms of sine, it would just kind of get shifted over, right? So you look for a 0 spot, okay? So you look for some sort of 0 spot in here. So here it crosses the x-axis right there. And it also crosses right here, right? So I could do sine, but it's probably going to be negative sine because normally sine goes up. So, but it's flipped. So this, if I was doing sine, it would be y equals negative. Still probably going to go down to 2 because that's my lowest point, the distance between my midline. So this is your midline. Between your midline and the crest, or the midline and the trough, the absolute value of that, that's going to be your a. And because this is facing down, it's a negative, and so that distance is 2. And so still going to have sine. But sine gets shifted over a little bit. It gets moved over -5 point something. So that's going to shift my thing a little bit. My b is still going to be the same because it still takes a total of, doesn't repeat itself to right here. So if I erase these numbers, so almost 16 and -5, so I can see that distance between 5 and 16 is 21. So that's where I get the 21. So it's still going to be 2 pi over 21 times x. So my b is still the same. But here it's going to get shifted a little bit, so that's going to change a little bit within this, and we'll talk about that in the next video. This gets shifted over 5 point something, so there's a little plus 5 point something kind of in there when you do sine, but I could write it in terms of sine. All right, so that's it for the finishing of the 6.3.